Welcome to Orensha PowerShell series. In this video, we're going to go over improving scripts. In my last video, we went over creating scripts and how to parameterize a script so that you can easily run it from the shell with different options. And this makes it easier for both you and other people to run without having to worry about the underlying code. And in this video, we're going to go over improving these scripts even more. And the first thing we're going to look at is returning objects with our scripts. Now, this is a best practice that you should adhere to because this is the way that your commands work. And really, this gives you the most versatility because it returns the bare objects that then lets you do whatever you want with them afterwards. So in the last video, we had returned our objects to a file using outFile. But what if we wanted to do something different with those objects, such as pipe them into another command or put them into a table or something else? So returning the bare objects just gives us the most options and adheres to the best practices of PowerShell. So that's the first thing we're going to do to improve this script. We're going to return the base file objects. And to do that, I'm just going to comment out these couple lines right here so that instead of piping the files that were returned into outFile, we're simply taking the files and leaving them in the pipeline, which is going to be returned at the end of the script. And the other thing we're going to want to clean up here before we move on is this write output. Now, if we leave the script the way it is right now, it's going to return these file objects and it's going to return this write output, which, if you remember from the last video, we want to avoid returning two different types of objects in the pipeline. So I'm going to comment out this for now as well. And we'll come back to ways that we can give this kind of information in the script without directly putting it in the main pipeline. And then the other thing I want to note in Visual Studio Code, when you have a variable that is not used in the script, it's going to let you know by putting a squiggly line under the variable name right here. So I no longer am using date. It's not necessarily bad to leave it in, but I want to point it out more as a tool that Visual Studio Code gives you to let you know when your variables aren't used. So then to wrap up this improvement, we're going to also want to come over here up to our parameters, and we no longer need this out path because we are not returning the objects to a file. So I'm just going to delete this. And now we only have these two parameters to work with, which is the file size and the directory. And now I'm going to move on to essentially the number one thing you can add to your scripts to take them from a basic script to an advanced script. And that is something known as Cmdlet Binding. So Cmdlet Binding enables a bunch of features, and by adding it to your script, you essentially let your script access those advanced PowerShell features. So it's very simple to add to your script, and you want to make sure that it's the first thing in your script, barring any comments, like we have here with our comment documentation that we went over in the last video. So right here, this is the first thing before the actual script begins. And Cmdlet Binding is started off with our square brackets, and then we just put in Cmdlet Binding with parentheses and then close our square bracket. And just like that, we've added a whole bunch of features to our script. Now we do have to specify those further in the script, but that is the main feature that turns them on in the first place. And the first one of those features that we're going to look at is mandatory parameters. So say that it doesn't make sense for you to specify a default value for a parameter, and you instead want to make sure that whoever runs the script puts in a value for that parameter. And in this example, we're going to choose file size. So instead of setting it to a default of 100, I'm going to remove this part, and then I'm going to add another line. And above this, we're going to put in our square brackets and then parameter. And then in parentheses, we put mandatory equals true. And then notice how there is no comma between this and the parameter name. So this is all one line, although we've broken it up into two for ease of readability. But when this is interpreted, it's going to read as one line. So this will apply to our parameter of file size. And by making it a mandatory parameter, now when someone runs this script, if they don't specify something for the file size parameter, then PowerShell will prompt them to add a value for that parameter. And this is where adding good names for your parameters comes into play. So I have file size for the name. It's very clear what this parameter is asking for, but you can add a little bit more help to this by adding a prompt that comes up with a help message that helps explain what the parameter is just a little bit more. And to do that, we'll simply put a comma after mandatory and then put help message equals and then our message. So there we've made it extra clear that the file size is in megabytes. And before we move on, I want to point out that this is called a decorator. And you can have multiple decorators per parameter. And the next one we'll look at is declaring the data type that you want for your parameters. So for file size, we want to declare that it's going to be an int. So we'll put our square brackets and put int inside of that. So this is another decorator that is declaring what this parameter is accepting. So for this one, for directory, we want to declare that it's going to be a string variable. So just like that, we've made our script a little bit more robust by declaring the data types that we're accepting in. So I'm going to save this now, and as you should periodically do, you're going to want to test your scripts before you make too many changes. So if something goes wrong, you generally know where the script went wrong. So let's run this in our current folder with our script name. And we're not going to declare something for either of the parameters. Our directory is going to default to downloads, but you'll see that it's going to ask us for that file size parameter. So then we can see here, it's saying type exclamation point question mark for help. So this is where that help message would pop up if we need it. So there it says enter file size in megabytes. So let's specify 50 in this case. And there we go. We collected all of the files over 50 megabytes in all of the users' downloads folders. Let's clear that. And then the next thing we're going to look at is adding an alias for our parameters. So this doesn't necessarily make the most sense for this script here, but I want to still point it out so that you know about it. So the parameter file size is fairly specific, but if you wanted to add an alias so that you could use a different name for that parameter, you can do that by adding another decorator, and we'll put that in our brackets and then specify alias. And then in parentheses, we'll put our alias name. So in this case, it's going to be size. So say we wanted to do that for directory. Instead of directory, we could put something like folder. So this just gives your script a little bit more flexibility in case a parameter is commonly known as something else. And this might make a little bit more sense for directory, where then someone running the script could either use folder or directory and still get to the same parameter. And then notice here with our decorators, you can keep adding decorators on new lines. And as long as it's not separated by a comma and it's all before your parameter name here, you can keep specifying those decorators and it's all going to be interpreted on the same line for that specific parameter that it's before. And then the next decorator that we're going to look at is forcing validation to force our input to either be between a certain range or to be a specific name. So let's look at that with file size. Say that we want to force file size to be above 50 because we don't want it to be anything too small, or else it's just going to return too many files. And really, we don't care about the files that are below 50 because it's not helpful in this scenario. So let's force our file size to be above 50 megabytes by adding another decorator. And this one is going to be validate range. And then we'll put in our parentheses 50 as the lower limit. And then we really don't care about the upper limit, so we'll use the max value for int. We do that by specifying int as a data type, and then we can just use colon colon and then max value. So that specifies the upper limit for int because we really don't care about the upper limit, we only care about the lower limit. So now we've added this decorator for validating range, and this is one way to specify validation. And the other way is to force validation to be a specific set of values, and we'll look at that with our directory. So we'll do the same thing, and instead of validate range, we'll use validate set. And then in our parentheses, say we only want to search specific directories. And this is helpful because every user profile is going to have a known set of directories, and we don't want someone to put in something like my personal folder. We want them to use folders that we know are going to be there, so there's no errors in our script. So say we want one of them to be downloads, and we want the other one to be desktop, and say we want documents to be in there, and then say the last one would be pictures. So we want to force the use of only these names. So this could also be applied with numbers, say for validate range, if we wanted to force it to either be 50, 100, 200, we could have done it that way as well. It makes more sense to do it here where we're naming a folder. So we used validate set to force the input to be one of these four options. So that way we reduce the likelihood that there will be any errors when we run this script. And the last thing we're going to look at is adding some commentary to our scripts. So like we looked at here at the beginning, we commented out our message that said what the script was doing. So we're going to look at a better way to do this, and that is through the use of something called Write-Verbose. So by adding Cmdlet Binding to our script, we enabled a feature called verbose, and this essentially gives us another pipeline to write information to that is more appropriate for these strings that tell us what the script is doing. So I'm going to uncomment this, and instead of write output, I'm going to use Write-Verbose. So just like that, we have our main pipeline that's going to have our file objects, but then we have a separate pipeline that's going to have these verbose objects. And then we can simply toggle this on and we'll see these outputs. So let's add a few more of these Write-Verbose strings to give a little bit more context to what the script is doing. And the first one we'll do is right here. So we'll do Write-Verbose, and then we can say that we're getting all of the user directories. And we can even specify our computer name here. And then we can add another one right here that says at this point in the script, we are looping through all of the directories to get the files over the specified file size. So now let's save our script and run this again, and we'll look at how to enable those verbose messages. And to do that, we simply use -verbose when we're running the script, and we can see right up here in yellow, it gave us those verbose messages. So this is a great tool for debugging your scripts if you want to look at what variables are during a certain point in your script. You can put them in the verbose messages, and then that way when you run the script normally you won't see those, but if you run them with verbose, it gives you a little bit more extra information about what's going on at certain points in your script. And then it puts it in a totally separate pipeline so that the functionality of your script remains true to the standard way that PowerShell works for all of its other commands. And we can see that here with the actual results of the script. And we have all of these objects that we collected through the specifications of our script. Now, there are other different kinds of information streams, such as one for errors, and I will cover those more in a later video, but for this video, I just want to encourage everybody to go and write your own script, think of something that you do either at work or something on your computer, but find a way to create a script with something that you commonly do, and then add all these different features like documenting your script and adding commandlet binding with these decorators to your parameters so that you can get used to how scripts are constructed. And before long, you're going to be an expert at writing scripts, and it's definitely going to take your skill set to a whole nother level. But that wraps up this video. In the next video, we're going to go over regular expressions. Until then, thanks for watching and have a good day.